Hello and welcome to the video lecture on Newton's third law, found in chapter 4.5. Newton's third law is commonly stated as, for every action there is an equal and opposite reaction. The big thing here is that for every force there is an equal and opposite reaction force. It does not matter, there are no exceptions. The two different things are the action and reaction. Forces act on different objects. They cannot act on the same object. That's why they do not cancel out. If the action and reaction forces were acting on the same objects, you would have a net force of 0. In this first example here, we have a fist punching a face with 2 newtons to the left. The reaction would be the face punching back at the fist with 200 newtons to the right. What most people miss when looking at Newton's third law is the fact that the masses of each object are different, and that's why we usually have some acceleration. When looking at Newton's third law, it is important to make sure that the directions are opposite and that you switch the objects. So for any action, object A exerts a force down on object B. The reaction, you need to switch the two objects, and you need to switch the direction. The reaction would be object B exerts a force up on object A. In this case here, with Newton and an elephant, Newton pushes to the right on the elephant. The elephant pushes back on Newton to the left. You switch each object and the direction when looking at between the action and reaction forces. One more thing here is if you look at this example, the elephant has a larger mass, so therefore it will experience less acceleration. Newton, having less mass, will experience more acceleration. This is because they both experience the same amount of force. In each case, just the mass is different. So here's a quick demo of Newton's third law. Here are my fingers. It takes my other hand to push my fingers back. I now take a clipboard. I push my fingers into the clipboard pushes back on my fingers. Newton's third law. Here we have another diagram showing action and reaction force pairs. Take a moment here and look through and see if you can find the missing reaction force. Don't get too confused with the positive and negative forces. Just realize that if there's a negative F1, for example, that just means it's in the opposite direction of the original F1. See if you can find that final force and take a moment to write it down in your notebook. Thank you very much and have a good night.